So calc-zero, as you know, or I hope you know from what we've been doing in class, is that you have to compare it against zero. Instead of comparing two functions against each other, now we're just comparing it against zero. So that means I have to get a zero on one side. And honestly, I think the easiest would be just to subtract 10 on both sides. So I'm rewriting the problem as 2 times the absolute value of x minus 3 plus 2 minus 10 is less than 0. You have to be really careful because like the way the inequality is facing really matters in this case. So make sure that you're careful on what side you move things to, where the 0 goes, which way the inequality goes. So you try and do it the simplest way you can. Just move all the terms from one side over to the other. In this case, the 10 was the easiest to move. So then we're going to have y1 is equal to 2 times the absolute value. And again, this works just like when we did equations. The only thing is that's different is how we interpret it in the end. But in terms of what we put in the calculator, it looks the same. Now, we also want to add that we want y1, remember that's this side here, y1 to be less than 0. y1 being less than 0, it means that we want where the y values are negative. That's what that means. Okay, so looking at the calculator, we have to enter all of that. I have a couple of options. I'm going to show you the one where you deactivate the function that we had before. Oh, this got shifted a little bit. Let's see if we can't get them to work. I'm going to turn it back on. This is where we were in the previous problem. I'm going to go into y is equal to. Now, I could delete the ones by hitting clear that are there. Or if I need those graphs for later, I could go down and use it in y3, and then just in my work write y3. So for example, I'm going to show you this because I want to teach you how to deactivate the other functions. So if I look at, I'm going to do 2 times the absolute value, and remember the absolute value was in math. You got to go to the numeric menu, choice number 1. Then, especially here, it's super important, x minus 3, that you end the parenthesis. If it doesn't give you absolute value bars, I got to use the arrow over to get out, or end parenthesis. Excuse me. Sorry. Then plus 2, and then minus 10. You could simplify the plus 2 minus 10 and just write negative 8. I'm just going to copy it down directly from what the problem said. And then I only want, if I hit graph right now, there's the stuff we had before and then this new graph. So that's really cluttering. So we can go into y is equal to, and do you see these equal signs? They're all highlighted. You go and highlight the equal sign. So you see my cursor is blinking here, and hit enter, and that deactivates the ones that are there, and then hit enter again. So now I only have y3 that's active, and then hit graph. And then you only get the part that's active. So yeah, we have to sketch just like before. We need the scale. I have already, it's at sum 6 still. It's still from negative 10 to 10, negative 10 to 10. And that fit, all the pieces that I need fit in there. So I'm going to draw, oh, I think I'll do blue for the scale here and the graph. Negative 10 to 10, and my graph, I'm hoping you're doing this with me, should look somewhat like this. And I don't forget to write the scale here. We gotta put that in as well. And I need to find this point here and this point here matters. Ooh, and I gotta be really careful now because, I'm gonna backtrack a little bit because I don't want to fill them in, because they may not be inclusive, and we are on the x-axis. And one of the requirements when you're doing using the graphing calculator to solve inequalities like this is that I want you to graph, if it's an inequality, the solution set on the x-axis. I need to see that there. That is part of what you do when you're asked to do it on the graphing calculator. All right, so looking at, let's click over here so we can see what we have. looking at, I thought that looks pretty accurate, right? So my whole job, I have to find this point right here, and I need to find this point right there. I'm going to go into calculate, so second calc. But instead of the intersection, I'm going to find calc-zero. So calc-zero. Now, calc-zero to me, especially with inequalities, are a lot easier to interpret. And when you get into AP Calculus and we assign you a TI 89, calc-zero is actually the easier, less cumbersome to do. So in this case, enter. I have to, you see where it says left bound? That means like where the cursor is, that's the little spider that's walking along our graph here. We need to make sure that we are to the left over here of the one. It can only find one solution at a time, so you have to make sure you're to the left somewhere over here of the one x-intercept. And then when we do the right bound, you have to make sure you're only to the right of the one I want to capture. So right now, I can see that I am, if I drew a vertical line down, I am to the left of the x-intercept I want to find. Enter. It puts a little arrow. This is the field I'm starting at. Make sure then you move to the right. And I keep going. You can just go immediately to the right. If you don't go to the right far enough and you haven't captured, like I have to make sure I'm to the right of this 0, then it'll say, oh, arrow dimensions incorrect or no sign change it, I think it says. So look, if I drew a vertical line, yes, I'm to the right of this 0 over here. So I'm going to hit enter. I don't want to guess. I just want you to tell me, calculator. Thank you very much. -1. So then I'm going to put that in. And my value or label of interest there, or point of interest, is the x-intercept. So I don't have to write an ordered pair because I know that the y is 0 there. And then we have to do the same for the other one. So we're going to find the other one. I'm going to do calc-zero again. But now the cursor is sitting on the cursor is sitting here on the one intercept. But I need to make sure that I don't get accidentally involved this one intercept. I need to make sure I'm to the right or to the left of the one intercept without interfering with the other one. I could be here. I could be here, 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 here. Any of this is to the left of the one intercept I want to find, which is this one over here, as long as I'm not to the left or on the other intercept. So enter, and then I keep going to the right. If I hit enter right now, right now, if I drew a vertical line, I would not be to the right of the other intercept. So I got to keep going, keep going, keep going, keep going. Right now, I would be to the right. If I draw a vertical line straight down, I'm going to be to the right. Okay. Enter. I don't want to guess, just tell me. Okay, that's 7. Alrighty, so that's the calculator portion of it, believe it or not. Now I have to interpret. So I have y1 here, y1, y1. All of that is y1. I'm just labeling the pieces there. I'm looking for where y1 is negative. Well, the y values are negative underneath the x-axis. So that means I'm looking for where the graph falls underneath the x-axis right there. So that means on the x-axis, it's going to be open, open. These are the x values where the y's become negative values. Right now, I just drew in the actual solution set to this. It is going to be -1 to 7, or if I did set builder x such that x is between -1 and 7, not inclusive. So they will look like that. And then again, remember to always represent, you got to put the input. This is the only thing here in the input that I need to add. And the x-axis here, what I drew on the x-axis needs to be added, like the solution set. Other than that, it looks just like when we solved.